This is Bob Capetta from the College of the Florida Keys, and this lesson is on solving equations. So if we're going to think of a number, add 3 and get 9, what number were we thinking of? That's in essence the question we're starting with. So let me go ahead and write down what that is. Thinking of a number, call it x, add 3, and the result is 9. To solve this, I need to isolate x. I can add the same number to both sides of the equation. So I'm going to add -3 to both sides, add -3 to the left side, add -3 to the right side. And then what do I get? I get x equals 9 minus 3. I get x equals 6. We can check that. Plugging 6 in for x. 6 plus 3 equals 9. And that checks nicely. Similar problem. If I have x minus 4 equals -11. What I like to do is to change all minus signs into plus negative. So make -4 plus -4. I need to get x by itself. I'm adding -4. So to get rid of the -4, I'll add +4 to both sides. Add +4 to the left, add +4 to the right. Keeping an equation in balance requires us to do the same thing to both sides of the equation. On the left side, I have x plus -4 plus +4, which would be x plus 0, or just x. On the right side, -11 plus 4 is -7. A little harder to check, but -7 take away 4 indeed is -11, and that would check. So we can add the same number to both sides of an equation. We can also multiply both sides or divide both sides. So if I look at 3x equals 15, I'm thinking of a number, multiplying it by 3, and the result is 15. Well, this time I'm going to divide both sides by 3. 3x equals 15. Divide the left side by 3, divide the right side by 3. 3x divided by 3. 3 divided by 3 is 1, that's 1x. Is 15 divided by 3 is 5, so x is 5. And then to check that, 3 times 5 is 15. Indeed it is. Throw in a negative number this time. How about saying -2x is 14. Whatever I do to one side of the equation, I should do to the other. So I'm going to go ahead and divide both sides by -2. Divide the left side by -2. Divide the right side by -2. And I get x is 14 divided by -2. A positive divided by a negative is -7. Do a mental check. -2 times -7 is 14. Indeed, it is. All right. Well, what we can do next is have a situation where we are going to be multiplying by a fraction. So our next example will be 2/3 x equals 12. So we can add the same number to both sides. We can divide both sides by the same number. We can multiply both sides by the same number. And in this situation, I think it makes more sense for us to go ahead and multiply both sides by the same number. I want to get x by itself. So I could divide both sides by 2/3, but that tends to be pretty complicated, dividing fractions. It's a little simpler to multiply both sides by the reciprocal. The reciprocal of 2/3 is 3/2. So multiply 3/2 on the left. 3/2 times 2/3 x equals 3/2 times 12. On the left side, 6/6, that's 1x. On the right side, I have 3/2 times 12/1. Now, there's a few ways we could do this. 3 times 12 is 36, divided by 2 is 18. I recognize that's how most students like to do it. The other possibility is to say 2 goes into 2 once, 2 goes into 12 6 times, 3 times 6 is 18/1 to give us 18. So let's do another one in that realm. Let's say maybe -3/4 x equals 9. We want to get the x by itself, so we're going to multiply both sides by the reciprocal. The reciprocal of -3/4 is -4/3. Multiply -4/3 on both sides. So we'll take negative 4/3 times negative 3/4 x equals negative 4/3 times 9/1. Now on the left-hand side, what do we have? Negative 4 times negative 3 is positive 12. 3 times 4 is 12. 12/12, 1x. On the right side, negative 4 times 9, negative 36 over 3. 3 into 36, how many times? 12 times. So we get our answer here, x is negative 12. If you prefer the other way to divide the fraction, 3 into 3 once, multiply the fraction, 3 into 9 3 times. Negative 4 times 3 is negative 12/1. So those are our sort of one-step equations. We can also do two-step equations that requires us to maybe both add and divide, something like 2x minus 4 equals 10. So I like to go ahead and make the minus sign a plus negative. We want to get x by itself. So I'm going to go ahead and add 4 to both sides first. Add 4, add 4. So now I get 2x plus 0 is 10 plus 4. 2x is 14. Whatever I do to one side of the equation, I should do to the other. So I'm going to divide both sides by 2. Divide by 2, divide by 2. 2x over 2 is 1x. 14 over 2 is 7. So my answer here is x equals 7. Let's do a couple more of those just so we get some practice. Next up, I will do 7x minus 1 is negative 15. We want to get the x by itself. So again, I'm going to make the minus a plus negative. Plus negative. I want to get the x by itself, so I'll add 1 to both sides, add 1 on this side, add 1 on that side. So now what do we have? 7x plus negative 1 plus positive 1. 7x is negative 15 plus 1 is negative 14. Let's go ahead and divide both sides by 7. Divide by 7 on this side. Divide by 7 on that side. 7 divided by 7, 1x. Negative 14 divided by 7, negative 2. So I get x is negative 2. So it's a standard two-step problem for solving equations. So the next type of equation that can get interesting is if we have x's on both sides. So for example, if I want to solve the equation 3x plus 1 equals 7x minus 15. What I'm going to do here is I'm going to change the minus to plus negative like I like to do. Recognizing there are x's on both sides, I'm going to get them all on one side by adding negative 7x to both sides. Negative 7x to this side, negative 7x to that side. If we add those together, 3x plus negative 7x is negative 4x plus 1 equals 7x plus negative 7x is 0 plus negative 15 is negative 15. And we want to solve it. This looks like a standard two-part equation. So we'll get rid of the addition first, add negative 1 to both sides. Now we have negative 4x equals negative 16. We divide both sides by negative 4. We get x is a negative divided by a negative is a positive. 16 divided by 4 is 4. Now you could try a little check. 3 times 4 is 12. 12 plus 1 is 13 when I plug it in on that side. 7 times 4 is 28. Minus 15 is 13. So that checks as well. So not a bad idea to continue to check. So let's do a couple more like that where we have x's on both sides to see how the equations work. So next up, I'm going to look at 8x plus 6 minus 2x equals negative 4x minus 14. Okay, well, we have the left side of the equation and the right side of the equation. Let's change the minus signs to plus negative. I want to simplify the left side. I have an 8x here, and I have a negative 2x here. 8x plus negative 2x is 6x. Plus 6 equals negative 4x plus negative 14. There are x's on both sides. So let's get them all on one side. I'll add 4x to both sides, add 4x on this side, add 4x on that side. 6x plus 4x is 10x. Plus 6 equals negative 4x plus positive 4x is 0, plus negative 14. We want to solve for x now, so we will add negative 6 to both sides. Add negative 6 here, add negative 6 there. And I get 10x plus 6 plus negative 6, 10x plus 0, 10x on this side. Negative 14 plus negative 6 is negative 20. Then we'll divide both sides by 10. 10x divided by 10, 10 over 10, 1x. Negative 20 divided by 10, negative 2. X equals negative 2. So we see the process. Simplify each side. Get all the x's on one side, then solve your standard equation. So let's do another one. What if I have negative 3x plus 7 equals 9 minus 3x? I like to change the minuses to plus negative, so I will do that. Make this plus negative. I want to get all of the x's on the same side. So I'll add 3x to both sides, add 3x to this side, add 3x to that side. Where does that leave me? Negative 3x plus positive 3x is 0, plus 7 is 7. 9 plus negative 3x plus positive 3x is 9. 7 equals 9? That's ridiculous. You get a situation like that that is untrue and all of the x's disappear, we say no solution. No solution on that one. All right. See if we can do one more problem here. Let's take a look at 30 plus 5 times x plus 3 equals negative 3 plus 5x plus 48. So again, we have a left and a right side, and we are going to simplify each side and see what happens. So 5 times x is 5x, 5 times 3 is 15. So on the left side, I get 30 plus 5x plus 15 equals, on the right side, negative 3 plus 5x plus 48. Let's look at each side. On the left side, I have 30 plus 15, which will give me 45 together with the 5x. So I have 5x plus 45. On the right side, I have 48 minus 3, also 45, and I have 5x plus 45. Well, that's interesting. I have the same exact thing on both sides. Now, our usual rule is to get all of the x's on one side. So I can go ahead and subtract 5x from both sides. Subtract 5x here, subtract 5x here. And now I have 0 plus 45 equals 0 plus 45, or 45 equals 45. Now, this is different from the one above, because the one above we had 7 equals 9, and that's ridiculous, and we said no solution. Here we have 45 equals 45. That's always true. When that happens, we're going to say infinitely many solutions. So you've got to see, is it a situation where your answer is simply not true, 7 equals 9, then no value of x will ever make that true. In this situation, the final answer is 45 equals 45, which means any value of x you choose to use will make that true. So there's infinitely many solutions there, and that's how we have to write our solution space. All right, and I think that will conclude this lesson.